So, can you think of a way? Okay, this just at the top, these are just numbers that we've maybe worked with at different points, especially on that little yellow card. It just says rewrite each of the following as a number base with an exponent. So like, what do I mean by that? Okay, so 25, I could write as 5 squared. That's kind of what I'm talking about. So can you think of a way to write these numbers as like a base with an exponent? And it's going to become important for some of the questions to be able to recognize that today. So can anybody just raise your hand, like, how could I write 64 as like something to a power? Okay, thank you for raising your hand. Was that what you were going to say?
I was going to say 8 to 7.
Exactly. So some of these have multiple. There's another way to write this. Does anybody know? I'm going to write this just real quick. This could also be written as 2 to the 6. So 64 has a bunch of options. 25 really only has one option. Okay, now, these, bless you, these are a little bit tricky. How could I write 1/2 as something to a power? And it would be okay to have a negative exponent. Yes, so this could be 2 to the negative 1. So that's going to be useful today for some of the questions. And it's okay to have a negative exponent. So how could I write 1/9 as like a base to a power? We could do the same thing, right? We could just do 9 to the negative 1. Can anybody else think of a way I could, what were you thinking? Yes, this would be 3 to the negative 2, because 9 is 3 squared, so you can use a negative exponent if you have a fraction. How could I write 1 over 125 as like a base to a power? And again, that's where that little yellow thing might come in handy. What do you think? Yes, 5 to the negative 3rd. And that's really the only, some of them have multiple options, some of them might only have one. I mean, technically, like, I could write this as, for any of these really, I could write this as 125 to the negative 1. 64, I could just write that as 64 to the first, or 25, I could just write that as 25 to the first. Technically, it's usually only helpful if you're going to use an exponent that is not using like to the first power. It's going to be helpful to do those. Okay, now here's what we're going to do first. We're going to solve exponential equations. I have 3 of these. You might want a calculator, but actually I think once we set them up, they're easier just to do by hand. But an exponential equation, just going to be like the ones in the example right below this, where your variable is going to be in an exponent. So like I'm going to have my x, but it's going to be up in an exponent. Okay, now there's a couple different types of these, so we're just going to practice these to start. So here's the deal. These, in this first question, I have 3 to the 4x, 3 to the 6x, and then times 3 to the 5x minus 14. Here is the deal. If all the bases are the same, which is what we have going on in this first question, if all of these are the same, we can just use exponent properties. Okay, so on this side, I just have my exponent is 4x. What do you do to the exponents if you multiply like bases? Do you guys remember? You're going to add. Okay, so basically, if all the bases are the same, which they're all 3 here, we're just going to make sure we use exponent properties. It literally like cancels all of those out, and I just have to remember on this side, if I multiply like bases, I would add the exponents. So really, this is what the problem turns into. 4x would be equal to 6x plus 5x minus 14. And that looks really complicated when I start, but actually that's all the equation would be. Just using exponent properties, the bases all cancel out, and the exponents have to be equal. You just have to add in between when you multiply like bases. So we would have just 4x, add these guys, 11x minus 14. I'm going to subtract 11x. So what would that be? Negative 7x equals negative 14. And so x is just going to be 2. And that's literally it. Now, if you don't have like bases, which I don't in the next question, that's where I'm going to bring in to play what we were literally just talking about. Okay, so I have 5 equals 2x to the negative 4, and then I just have 25. So what I want to do is see if I could rewrite 25 as 5 to a power. What would 25 be as 5 to a power? 5 squared. Okay, so if the bases match, now I made them match, that forces these exponents to be equal to each other. So then literally, all I'm doing, I'm just literally equal. So just do 2x minus 4 equals 2, and then that's the equation you have to solve. But in that case, I had to create a situation where the bases were the same. So then I'm just going to add 4. I get 2x equals 6, divide by 2, x is 3, and that's all you have to do. The trickiest kind of exponential is going to be like what I have on this last one, where neither one of the bases are the same. So I've got like a 32 and I've got an 8. You're not writing 32 as 8 to a power. So I'm going to grab my little yellow piece of paper here real quick. Okay, so I need to write both of these to the same base. So I need to write something to a power for 32 and 8. Does anybody know what base I would use? 2. Okay, so like if I'm looking on the line with the 2, see, here's the 8, here's the 32. So I got to use 2. So 32, and if I'm in, as you go across here, like this is 2 squared, 2 to the 3rd, 2 to the 4th. 32 is 2 to the 5th. So I'm just doing 2 to the 5th, and then I have this exponent, the x minus 1. All right, I have to make both of these bases the same. Now 8 I can rewrite as 2 to the 3rd, and then that had, 2x plus 3 as its exponent. Okay, now this is going to be a couple properties, but when you do a power to a power, do you guys remember you just multiply these exponents, right? As long as I got the same bases, these are going to have to be equal. If I have a little set of parentheses around that though, what I'm going to have to do is take 5 times that x minus 1, power to a power, and then the other side would be 3 times 2x plus 3. But that's after you set up that exponent property. The bases are the same, so it basically cancels out. If the bases are equal, it forces the exponents to be equal. We're just applying a little exponent property there is all we're doing. So this one's a little more complicated because I got to do distributive property here. So I get, let's see, 5x minus 5, and then 6x plus 9. Completely up to you. If it's me, I try to keep my variable positive, so I would subtract 5x, but that is not the step you have to make. If you get the same answer as me, you're doing it right. But I'd have negative 5 equals x plus 9 minus 9, so negative 14 would be my answer. So they're not bad, but you do have to make the bases match up before you can set the exponents equal. If you can make the bases match, the exponents are forced to be equal to each other. If you are multiplying like bases like I was in this first one, you would add those exponents. This one, it just set them equal to each other because it's just 5 and 5 on either side. This one, if you had to rewrite and you have an exponent, when you do a power to power, you might have to do a little distributive property like I did there, but it forces those exponents to be equal. And use this little yellow piece of paper if you're having trouble writing the base, because I think that might help you, especially if you're not familiar with the numbers. Does anybody have a question? Okay, now at the bottom of this page, which I probably should have put this on the back, but I'm just going to do a little introduction to a logarithm for you. And really, we don't have to write much here. I kind of wrote it all here. So what I have are 2 formats. What you guys are used to seeing so far in this unit is called exponential form, where I have an exponent. What we're going to convert to today and kind of introduce today is what we call logarithm. So these two are equivalent. They're just in 2 different forms. So the first one's an exponential form. We're going to work on converting to log form today. And what the log is the log is an inverse of an exponential. So if you've ever seen that button on your calculator that says LOG, it stands for logarithm. And I'll probably just call it a log because it's less words to say. Okay, now exponent here, this is what I want to show you. Exponent, if you have b to the x, is going to be the logarithm in the equation. So if you guys look here, the little subscript, I would read this as log base b of y equals x. So the base of the exponent, in log form, it's what we call the base or the little subscript of the log. and it says the base b is the same as the base of the logarithm, just to let you know. Now, rules for exponentials. Remember, the b value cannot be 0 if you have an exponential, and the b value has to be greater than 0. It just means it's positive. Okay, now here's the deal. Positive number, right? B has to be a positive number raised to any power. I could literally positive, negative, whatever, cannot equal a number less than or equal to 0. It can't happen. You can't get a negative if you put something in an exponent. We're going to talk about that in 1 second. So the thing to take away here, you can't take the log of a negative number because it's, or 0, because it's considered undefined. All right, that's all this says. Can't take the log of a negative number or 0. If you were to try to do it on your calculator, it wouldn't let you. Like it would tell you it was an error message. And the reason for that is just like here. There is no, like if I put in -2, right? If I made x -2 right there, it'd be 1 over 36. It wouldn't be -36. This does not have any number you can plug in for that exponent that would ever make that equal to a negative number. So you cannot take the log of a negative number because it doesn't exist. There's no possible way to do it. Now we're actually going to just convert some formats here on the back, but that's the basic gist behind the logarithm. It is the inverse of an exponential. Okay, you are not evaluating or doing anything here. We're just going to convert these. So these guys in example 2, they're in exponential form because you see an exponent, okay? Now, we're going to change these to log form. So I'm just going to use that definition. These are all true statements, right? 729 is 9 to the 3rd power, 32 is 2 to the 5th. These are all true statements. We're just going to convert them to what we call log form. Okay, now here's how I do this. The base of your exponent, which is going to be 9 for this first question, is going to become the base of the log, which is like a little subscript. So I just tell people to do this. I'm going to swing this over to the other side of the equation. When I do that, that's going to drag that exponent down out of being an exponent, and it's going to be on the level with the rest of the question. So I would write it like this, log, and then you have like a little subscript. The base of the exponent becomes the base of the log, so that's log base 9, and you just keep the 729 right where it's at, and that's equal to 3. True statement. We're not evaluating or doing anything these, we're just converting them really quick. So all you're going to do, base of your exponent, I'm just going to swing that across the equal sign. Base of that exponent is going to come down, be the little subscript or the base of the log. You just keep the 32 right where it's at, and when you convert it to the log form, the exponent just comes down on the level with the rest of the equation. So that just becomes a plain 5. You no longer have an exponent when you're in log form. Okay, now the other two, the only thing I did, I just kind of wrote them like a little bit backwards from the first two, but these are the same concept. So this says anything to the 0 power is 1, right? But this time I'm going to swing it the other way across the equal sign. So the base of the exponent, I'm just going to bring down that 0. This would be the log base 12 of 1. So it's just kind of like backwards the way the equation's written. But we're just converting it to log form. You're not solving for anything. There's no variables here. All right, and then again, I just have one more base. This is a true statement. 10 to the -2 is 1 over 100. Swing this base of the exponent. Bring that -2 down on the level with the rest of the question. This would be log base 10 of 1 over 100. So base of the exponent just becomes a little subscript for the log, and then the exponent comes down on the level with the rest of the question when you convert these. Is anybody having a question at the moment? Okay, now my example 3 just reverses that. So I'm going to give you the log form, and we're going to convert it to being an exponential. All right, so I'm not solving anything here. We're just going to convert these really quick. So your base of your log, the word log is going to disappear when you convert this to exponential form, and these should all be true statements. So I'm going to swing the base 4. Now, when it's a subscript in the original, we're going to make it a base in the other, so I'm just going to swing that. I'm going to get rid of the word log. We're just going to copy the 1024. That 4 is going to push that 5 up in the air to be an exponent, And so that would read in exponential form, 1024 is 4 to the 5th. And if you guys look at the little yellow paper, 4 to the 5th power, I promise, is 1024. So you get rid of the log, you're going to swing the base over to the other side to convert these. This is log, the subscript is 1/3. If I swing this over, you get rid of the word log, you just leave the 27 right there. The base of the log becomes the base for your exponent. So in this case, I'd take 1/3, and you're just going to push that -3 right up in the air, and that's going to become an exponent. So when you're in exponential form, you're going to have an exponent. And then I got one left. True statement. If I swing this over, just get rid of the word log, leave the 1/100 right where it was at, and then that 10 is the base of the exponent. It's going to push that -2 up in the air. It'd be 1/100 is 10 to the -2. All true statements. Does anybody have a question? Okay, now, the only log you can actually do on your calculator, which is what it's programmed for, is called the common logarithm. And this is a log with a base of 10. So the little subscript is 10 for the common log. Can do on the calculator. Otherwise, if it's any other base, you cannot do it on the calculator, because we'll do some stuff a little bit later on, and I'll show you how to do it. But a log base 10, if you just click the log button on your calculator, it's programmed to be what we call the common logarithm is base 10. So I'm just gonna make something up. Let's say I had the log base 10. I'm just making something up, like 6. This is not a nice number if you'd actually calculate it. But this is the same as just log of 6. So if you ever see a log just written with no little subscript, the assumption is it's a base 10. So if you just see the word log, you go ahead and assume base 10. So just to show that to you guys, because I think I have one like that on the next group that we're going to do. All right. Now, this is the part where that lovely little yellow piece of paper might come in handy to you. Okay, now, on the quiz and test for this unit, on these types of questions, it's going to ask you to evaluate a logarithm, and you cannot use a calculator to do this. And you can't do it anyway because it's not base 10. There's no way to type it in there. So I'm going to show you how to do this. All right, if it says evaluate, you are going to find a value. Like you're actually going to find a number. Like, so this will be, evaluate means find a value. So we're going to find a value. What I would tell you to do for any of these questions, and you can pick your favorite letter. I'm boring, so I'm just going to pick X. All right, so for each of these questions, I'm going to set these equal to X. Just every single one. I'm going to go through here. We're going to actually find the value of this, and I'm going to set them equal to X. Now, the reason I'm doing that, I'm going to convert these to exponential form real quick. And you guys are going to see if you can tell me what that exponent would be to make this statement true. So I'm going to swing this here, get rid of the log, and I'm going to leave the 81 where it's at. And when I swing that 3 to the other side, the base of the log becomes the base of the exponent. So it's going to push that x up in the air to be in my exponent. Now, if you want to tell me the answer to the question, you got to tell me what would you plug in for x to make that true. Because 81 is 3 to a power. Does anybody know what power it is? 4, right? Okay, so this is 3 to the 4th. My answer to the question is just going to be 4. Some of these will be harder than others. All right, if I swing this 5 over here, I'm going to get rid of the log, convert this to exponential. The 25 is going to stay where it's at. Base of the log, little 5, little subscript, becomes the base of the exponent. So I'm just going to swoosh this 5 across the equal sign, push that x up in the air. What should x be there? 2. That's your answer. 25 is 5 squared. The exponent is where you got the variable, so the 2 would be the answer. All right, now this one's tricky. So this is actually going to kind of use some of the stuff we used on the front. So 27 stays where it's at. Just base of the log becomes base of an exponent, so I'd get 27 equals 9 to the x. Can you write 27 as 9 to a power? No. Okay, do those two numbers have anything in common that you could write them both with the same base? Exactly. Okay, so this is kind of like the problems we did on the front. So 27, 3 to the third, 9, this is 3 squared, and then I have that to the x. So this is kind of like those questions. It's actually not as complicated as those questions that we did on the front, but once you set this up, you can do it. So if the bases are equal, so 3 and 3, that forces the exponents to be equal to each other. So I'm just going to put together a tiny little equation to the side. This would be 3 has to be equal to the 2x, because if the bases are the same, it forces those exponents to be equal. This guy would just be 3 over 2 as the answer. And you can check, right? If I do, I'm going to grab my calculator real quick. If I do 9 to the 3 over 2 power, that is equal to 27. Right? That's all you got to do. You can check. All right, now this is the one like I was just mentioning to you. If you don't see a subscript, which I don't in this next question, this just says log of 1 over 1,000. And I like to just, for myself, I'll just write the little subscript in because it gives me something to swing to the other side of the equation when I convert it into an exponential. But if you don't have a base, it's assumed to be base 10. So swoosh this over here. This is 1 over 1,000. And then base of the log becomes base of the exponent. So the 10 is going to come over there, be a normal size number, and it's going to push that x up into the air to be in an exponent. Okay. Does anybody know 1,000 is 10 to what power? The third, right? Okay. So if you want to do this automatically, I'm just going to do it in 2 steps. This is 10 to the third. If you have a fraction, it's kind of like unsimplifying a negative exponent. I'm going to bring this up to the top. This would be 10 to the negative third power. And I know we keep saying it's not simplified if it's got a negative exponent, which is true, but in this question, that's going to help me do the problem. If my bases are the same, that forces my exponents to be equal. So in this case, my answer would just be -3. And you don't have to write all those steps out. If you look at 1 over 1,000 and you're like, that's 10 to the -3, that's fine. You don't have to write a bunch of work out. I'm just trying to show you where it comes from. Okay, now the last two are very tricky. So I'm going to get rid of the log, just change it to an exponential form. So I'm going to keep the 32 where it's at. Base of the log, little subscript, becomes the base of the exponent. So I'm going to put 1/2 over here, and that's going to push that x up in the air to be in an exponent. All right, now I know we did one that had 32 on the front. These I'm going to use both base 2. So 32, 2 to the 5th. 1/2, if you guys remember from the front, is 2 to the -1. If you can make the bases the same, which I just did there, that forces our exponents to be equal. So in this case, we would just have 5 equals -1 times x, which would just, I would divide both sides by -1. So my answer there would be -5 to make that equation true. And then I got one more and I'm going to shut up. All right, so base is 64 here. So get rid of the log, just delete the word literally when we convert this to exponential. Leave the 1 over 32 where it's at. Base of the log, which is a 64, we're going to push that x up in the air, becomes the base of my exponent. So 64 to the x. This one is super tricky because I don't think 2 to the 6th power is on the little card. So 32. 32 is 2 to the 5th. If I got a fraction, I'm just going to write it as 2 to the -5th. I'm going to add this up on the board because this is not on the card here. And if you guys have your card, little card, I feel like this comes up sometime. You might just write like 64 on there is 2 to the, that's 2 to the 6th. I don't even know what 3 to the 6th power is, but 2 to the 6th power is 64. So you might add that just on the edge of your little yellow card. So you got that. So this would be 2 to the 6th and then to the x. So power to a power, I would multiply the exponents there. So this would be 2 to the 6x power if I simplified that just a little bit. If your bases are the same and we're set equal, that forces our exponents to be equal. So the little tiny equation I would solve there, we would just have, I'm writing too big, -5 equals 6x, divide by 6. So negative 5/6 would be my answer for that last one. Is anybody having a question? And you can check, right? If you actually do, like I could do 64 to the negative 5/6 power on my calculator. It's going to not be on the screen because I'm an idiot, but it's going to give me a decimal. So I'm going to hit math, enter, so you guys can see, and that's 1/32. So you can check any of these questions. Just plug it back into your exponential form and then see if it gives you, you might have to convert it to a fraction real quick, but it shouldn't be too bad.